Engineering drawings are the language of design, meticulously conveying complex information about the shape, dimensions, materials, and assembly of physical objects. These technical blueprints guide the creation of everything from bridges and buildings to microchips and medical devices. Given the critical nature of this communication, ensuring accuracy and traceability throughout the design process is paramount. This is where revision control emerges as an indispensable practice in the engineering world. Revision control, in essence, is the systematic management of changes made to engineering drawings. It provides a detailed history of modifications, clearly indicating who made what changes, when, and why. This meticulous record-keeping is not merely bureaucratic diligence. It is the bedrock upon which sound engineering decisions are made, preventing costly errors, ensuring accountability, and fostering efficient collaboration among design teams. Imagine a team of engineers working on a complex project like an aircraft engine. Each component undergoes multiple design iterations, with engineers constantly refining and improving upon previous versions. Without a robust revision control system, chaos can easily ensue. Designers might inadvertently work on outdated drawings, leading to costly rework and project delays. Tracking down the source of errors becomes a nightmare, and collaboration among team members devolves into confusion. This introductory exploration highlights the fundamental importance of revision control in engineering. In the following sections, we will delve deeper into the practical aspects of this practice, exploring its real-world implications, outlining a clear implementation process for CAD software, and providing valuable insights into best practices and common pitfalls to avoid. At its core, revision control is the systematic tracking and management of changes made to a file or set of files. In the context of engineering drawings, this means maintaining a comprehensive history of every modification made to a design, no matter how small. This history, often referred to as a revision history or audit trail, captures crucial information for each change. Revision number, a unique identifier assigned to each iteration of the drawing. Date and time, the exact moment the change was implemented. Author, the individual responsible for making the modification. Description, a brief explanation of the change, outlining its purpose and impact. This meticulous documentation serves as a single source of truth for the design, ensuring that everyone involved in the project can access and understand the evolution of the drawings. This transparency is invaluable for error prevention. By providing a clear audit trail, revision control helps identify the source of errors and prevents the use of outdated or incorrect information. Accountability. Knowing who made what changes and when allows for clear accountability, facilitating communication and problem-solving. Collaboration. Revision control systems enable multiple engineers to work on the same drawing simultaneously, merging their changes seamlessly and avoiding conflicts. Version comparison. The ability to compare different revisions side by side highlights changes, making it easier to understand the design's progression. In essence, revision control transforms engineering drawings from static documents into dynamic records of the design process. By embracing this practice, engineers gain a powerful tool for mitigating risks, enhancing collaboration, and ensuring the integrity of their designs. The consequences of inadequate revision control can be far-reaching and costly, potentially jeopardizing entire projects and damaging reputations. Consider the following real-world scenarios. A bridge construction project faced significant delays and budget overruns due to a lack of proper revision control. Contractors inadvertently used an outdated version of the structural drawings, leading to the fabrication of incorrect components. The error was only discovered during assembly, necessitating costly rework and pushing back the project timeline. A medical device manufacturer had to issue a costly recall after a design flaw was discovered in one of their products. An investigation revealed that the flaw stemmed from an undocumented change made to the drawings during the design phase. The lack of a clear revision history made it impossible to trace the source of the error, leading to a lengthy and expensive legal battle. A space agency experienced a significant delay in launching a satellite due to a discrepancy in the design specifications. It was later determined that different teams had been working with different versions of the same drawing, resulting in conflicting information. The launch was postponed until the discrepancy was resolved, costing millions of dollars in lost time and resources. These examples underscore the critical importance of implementing and maintaining robust revision control systems in engineering. The seemingly minor inconvenience of meticulously documenting changes pales in comparison to the potential financial, legal, and reputational risks associated with poor revision control. Section 4. Implementing Revision Control, a step-by-step guide for CAD software. Modern CAD software offers powerful tools for managing revision control. While features vary, the principles remain consistent. Here's a general guide to get you started. Step 1. Choose a revision control system. Most CAD software has built-in revision control or integrates with systems like Git. Step 2. Set up your project. Create a new project and define the structure. Step 3. Create your first revision. New drawings are automatically assigned as the first revision. Step 4. Make and commit changes. Save your changes regularly and commit them as new revisions. Step 5. Add a descriptive commit message. Include a detailed message explaining the changes. Step 6. Use branches for parallel work. Create separate branches for parallel development. Step 7. Merge branches and resolve conflicts. Merge branches back into the main design and resolve conflicts. Follow these steps to implement revision control in your CAD workflow. Best practices for effective revision control in CAD. Implementing a revision control system is crucial. Here are key considerations. Establish clear naming conventions. Consistent naming helps everyone understand the organization. Write detailed commit messages. Explain changes, reasons, and impacts. Commit frequently and incrementally. Use branches strategically for specific features. Regularly review the revision history. Lastly, back up your data to prevent loss. Adopt these practices to enhance your design process and collaboration.